So if you're putting together a rig for local AI, you are facing one of the most interesting choices in hardware right now. Do you go with the tried and true powerhouse, the RTX 4090 with all its VRAM, or do you bet on the future, the super efficient new architecture of the RTX 5080? It is a way tougher call than you might think, so let's dive in and figure this out. We're all kind of conditioned to believe this, right? When it comes to tech, newer just has to be better. But here's the thing. When we're talking about running huge language models on your own machine, that simple rule goes right out the window. The obvious choice here might actually be the wrong one. And this really captures the whole battle perfectly. In one corner, you've got the RTX 5080. It's the future-proof architect, built on the brand new cutting-edge Blackwell architecture, and it's promising all this amazing efficiency and new AI tricks. And in the other corner, you have the RTX 4090, the VRAM veteran. It's the undisputed champ of the last generation, and it's holding on to a massive advantage in one absolutely critical area: memory. All right, to get to the bottom of this, here's how we're going to break it down. First, we'll talk about the new GPU dilemma itself, why this is such a tricky choice for AI specifically. Then, we're going to dig into why VRAM can absolutely be king. After that, we'll look at the promise of the new Blackwell architecture in the 5080. Then, the fun part, the benchmark showdown. We'll peek at some other contenders, and finally, we'll wrap it all up and help you choose your AI weapon. So let's get right into the thick of it. What makes this choice so uniquely difficult? Well, it's because this isn't like gaming, where the goal is simple: just get more frames per second. Nope. Local AI plays by a completely different set of rules. For AI, it's not just about how fast your GPU can run, it's about what your GPU can run in the first place. The sheer size of the AI models you want to experiment with creates this hard limit, this bottleneck, that pure raw speed just can't muscle through. And that brings us to the single biggest argument for the older card, the RTX 4090. It's VRAM. When you're dealing with large language models, having enough VRAM isn't some nice-to-have luxury, it's an absolute non-negotiable necessity. This analogy of a workbench is just perfect. Think about it. If the AI model is your project, the VRAM is the size of your workbench. If the project is physically too big to fit on the bench, you just can't work on it. It doesn't matter how fast or fancy your tools are. A smaller bench means you're stuck with smaller, less powerful projects. Simple as that. Now, take a look at this data from the local Llama community. This shows you exactly why this is so critical. A 7 billion parameter model, okay, that's manageable. But look what happens when you jump to a 14 billion parameter model. Even when you compress it, you're looking at around 10 to 16 gigs. Now jump to a 32 billion parameter model, boom, you need at least 20 GB. All of a sudden, the 16 GB on the RTX 5080 looks really tight, while the 24 GB on the 4090 opens up a whole other class of models you can play with. And I mean, this quote from a user on the local Llama subreddit just says it all, doesn't it? For the people who are really pushing the boundaries of what you can do at home, capacity, that raw VRAM number, often beats everything else. That's the core argument for the RTX 4090. But wait, that's only half the story. Now we have to talk about the RTX 5080's secret weapon, its brand new Blackwell architecture. And let me tell you, this is not just some small incremental update. This is a massive leap forward in how these chips are designed to tackle AI from the ground up. To really get what makes Blackwell so special, you have to see where it comes from. This isn't just a gaming architecture that had a few AI features bolted on. No. This is the same core technology that is powering NVIDIA's gigantic data center scale AI supercomputers. The RTX 5080 is basically getting that top-tier enterprise-grade DNA. So what does that DNA actually give us? Well, you're getting 5th-gen Tensor Cores built specifically for these AI calculations. You get brand new, super efficient data formats like FP4 and FP6. It's got a 2nd-gen transformer engine, which is the literal heart of models like ChatGPT. And maybe best of all, it does all this while sipping less power. Okay, let's zoom in on that headline feature, FP4. This is a potential game changer. Being able to run calculations at 4-bit precision means you can cram bigger models into the same amount of VRAM and run them much, much faster. It's Blackwell's direct answer to the whole VRAM problem. But there's always a but, isn't there? And here it is. This is the big catch for the 5080. Having native FP4 support is amazing technology, but right now, the actual software and the models that can use it are few and far between. So buying an RTX 5080 for AI today, it's a bet. It's a bet that the entire software ecosystem is going to catch up and adopt these new formats. You're buying into the future. All right, enough with the theory. We've got the VRAM veteran versus the future-proof architect. Let's stop talking and see what actually happens when we put them head-to-head in some real-world tests. So just looking at the raw specs on paper, the story gets even more complicated. The 4090 has that clear lead in VRAM, a wider memory bus, and a little more bandwidth. But then look at the 5080. It boasts way higher theoretical AI performance, or TOPS, and it does it all while using significantly less power. The trade-offs are just staring you right in the face. Okay, so this first benchmark really shows off the 5080's efficiency. When you're running a model that fits comfortably within its 16 gigs of VRAM, that new Blackwell architecture just sings. It's generating tokens nearly as fast as the 4090. The performance gap is incredibly small, which just proves how potent that new design really is. But then you switch to a really memory-intensive task, like generating images with Stable Diffusion XL, and the tables completely turn. Here, the 4090's extra VRAM and wider memory bus give it a clear, noticeable advantage. It's just plain faster. This perfectly illustrates how the right choice really depends on what you're actually going to do with it. Of course, the 5080 and 4090 aren't the only two GPUs in the world. It's definitely worth taking a quick peek at a couple of other options that might actually be a better fit depending on your needs and your wallet. So if budget is absolutely no concern, well, then the RTX 5090 is the king of the hill. It's the best of both worlds. You get the new Blackwell architecture and a whopping 32 GB of VRAM. Then, on the other end of the spectrum, you've got Apple's M-series chips. Now, you're not going to be training models on these, but their unified memory makes them insanely efficient for just running models for inference, usually in a super quiet, low-power machine. Okay, we've gone through VRAM, architecture, and the benchmarks. Let's bring it all together and figure out how you should make this final call. Because remember, there's no single best GPU here. There's only the best GPU for you. So ultimately, it really just comes down to your main priority. If your number one goal is to run the absolute biggest, most complex models that are available today, then the 24 gigs of VRAM on the RTX 4090 makes it the clear winner, hands down. But if you value having the latest and greatest tech, you want higher efficiency, lower power bills, and you're willing to bet on the future of software support for things like FP4, then the RTX 5080 is your card. And, of course, if you just want it all and budget is no object, the 5090 is waiting for you. This quote just boils it all down to its absolute essence. The 5080 is the smart, efficient choice that's banking on the future. The 4090 is the brute force, raw power choice for today's heaviest AI lifting. It really is a classic battle of brains versus brawn. And all this leaves us with one last big thought. We've been so focused on VRAM and compute power, but as these AI models just keep getting exponentially bigger, what's the next bottleneck going to be? Is it going to be memory bandwidth, the speed of the connection between GPUs, or something totally different that we haven't even thought of yet? The race is on, and it's going to be absolutely fascinating to watch. Thanks for joining me for this explainer.